Assalamu alaikum. How are you, dear students? In this video, we are going to talk about and explain the converse of Thales theorem. In the last video, we talked about Thales theorem, and in this video, we're going to talk about and explain the converse of Thales theorem. As for an objective, to prove parallelism using converse of Thales theorem. How to prove two lines are parallel using the converse of Thales theorem. Let's recall back. From the previous video, also on page on page 84 and 85 on your Ahliya books, we started the Thales property. This is a recall. If D and D prime be two non-parallel straight lines, these are D and D prime are two non-parallel straight lines. A, B, C are 3 points on D, and A prime, B prime, C prime are 3 points on D prime. Then we have, as Thales property, we have AB, and such that before stating the Thales property, we should have an essential condition: the three lines AA prime, BB prime, and CC prime are parallel. So we have AB over AC, AB over AC equal AB prime over AC prime. In a triangle, when we start from the same point in a triangle, we have triangle ABC, line D cuts AB and AC at the 2 points B prime and C prime such that D is parallel to BC. Then Thales theorem says that AB prime over AB equal AC prime over AC equal B prime C prime over BC. Okay, as you can see here, since we started these four segments from the same point, which is the point of intersection of the two lines AB and AC, which is A, we said AB prime over AB. We are in these four segments, we are starting always from A, equal to AC prime over AC. Then we can continue to say is equal to B prime C prime over BC. Also here, we may have derivatives for Thales theorem. We may say AB prime over B prime B equal to AC prime over C prime C. But we can't continue to say that it's equal to B prime C prime over BC. No, because these AB prime and B prime B, AC prime, C prime C are not all starting from the same point A. Only in the case when these four segments, the first four segments, start from the same point A, we may continue to say equal to B prime C prime over BC. Also, this Thales theorem, we may permute it. We may say AB over AB prime equal AC over AC prime equal BC over B prime C prime. We may permute all the ratios. Okay, we may have also other derivatives. We may say AB over B prime equal to AC over C prime. That's it. It's also a derivative of Thales property. We may say also AC prime over AB prime equals C prime C over B prime B. Also, this is a derivative. Okay, and so on. Now, let's continue with our new objective, which is the converse of Thales theorem. Converse of Thales theorem on your books on page 87, Ahliya book. As you may see down under the activity converse, we have Let ABC be any triangle. B prime is a point of AB and C prime is a point of AC, distinct from A and C. Distinct from A and C means that, and distinct from A and B, that B prime cannot be A and cannot be B, and C prime cannot be A and cannot be C. This is the meaning of distinct from A and B and distinct from A and C. Okay, what do we have also here? If AB prime over AB equal AC prime over AC, then BC is parallel to B, sorry, then B prime C prime is parallel to BC. This is the converse of Thales theorem. So here we have, if we have AB prime over AB equal AC prime over AC, then B prime C prime is parallel to BC. This is how to prove two lines are parallel by using the converse of Thales theorem. Let's take the application on page 88. Application 3. ABC is an isosceles triangle of vertex A. B prime is a point of AB and C is a point of AC, and C prime is a point of AC, such that AB prime equal 1.5 centimeters and B prime C prime equal 2 centimeters, and we have AB prime over AB equal AC prime over AC equal 1 over 3. Calculate AC prime, BC, and AB. Calculate AC prime, BC, and BC. This time is given to you to think about this application and try to find a solution. I'll give you a hint. We have AB prime over AB equal AC prime over AC. So we may use Thales theorem, the converse of Thales theorem, to prove that B prime C prime is parallel to BC. Calculate AC prime, BC, and AB. We have to calculate AC prime, BC, and AB. AC prime, we don't have it. We have AB prime over AB equal AC prime over AC equal 1 over 3. So by converse of Thales theorem, B prime C prime is parallel to BC, as I gave you the hint, and AB prime over AB equal AC prime over AC equal B prime C prime over BC. Since we have B prime C prime is parallel to BC. How did we know that B prime C prime is parallel to BC? By the converse of Thales theorem, because we have given as ratios AB prime over AB equal AC prime over AC equal 1 over 3. So this means that B prime C prime is parallel to BC, and we can apply Thales theorem, which is AB prime over AB equal AC prime over AC equal B prime C prime over BC. Then A B prime C prime is equal to A B C alternating angles. Also A C prime B prime equal ACB alternating angles. but ABC equal ACB. So we have also that triangle AB prime C prime is an isosceles triangle, since we have AB prime C prime AB prime C prime is equal to AC prime B prime. So triangle AB prime C prime is isosceles. Therefore, AC prime equal AB prime equal 1.5 centimeters, because we have AB prime given 1.5, and now we have AC prime equal AB prime equal 1.5, base sides of an isosceles triangle, AB prime and AC prime. So now we calculated AC prime. Now it's required to calculate BC. Think about it. BC equal how much? How to calculate BC? So we go back to Thales theorem. Let's check if we have B prime C prime. We have B prime C prime. Then we can calculate BC, which is B prime C prime over BC equal 1 over 3 by cross multiplication, and we substitute B prime C prime by 2. So by cross multiplication we get that BC is equal to 6 centimeters. We still have to calculate AB, and we have AB prime. We still have to calculate AB, and we have AB prime equal 1.5. So we take this ratio and this ratio, and the same by cross multiplication. We substitute AB prime by 1.5, and by cross multiplication we get AB equal to 4.5 centimeters. AB equal to 4.5 centimeters, so AC is equal to 4.5 centimeters, because they are base sides of an isosceles triangle. Thank you for watching. I hope you will understand this chapter very well, and we will continue in the next videos to explain the other objectives. See you later.